I've always loved that optimistic vision from Star Trek, the replicator.
Oh yeah, just ask for something and it appears out of thin air.
Exactly. And it feels like that fantasy is starting to, well, to bleed into reality. We're doing a deep dive today on a system from MIT researchers that they're calling speech to reality.
And it does pretty much what it says on the tin.
It does. You give it a voice command, and it produces a physical object,
Yeah,
a shelf, a chair. I think I even saw a dog statue in, what, 5 minutes?
that's right. And what's so fascinating is that it's a huge step toward what we're calling physical AI.
Okay, so more than just automation.
Much more. This is where AI and robotics really converge. The machine isn't just following a program, it's perceiving your intent, reasoning about the physical world, and then actually interacting with it.
So let's break that down. How does it work? What's the technical magic that turns me saying I need a simple stool into an actual physical school?
Well, it's a really elegant pipeline. It starts with something we're all, pretty familiar with now, natural language processing.
Right, an LLM to understand the request.
Exactly. That translates your intent into an input for a 3D generative AI, which creates the initial, the digital mesh.
But wait, I've seen what those 3D AIs produce. They make things that look incredible, but, you know, they completely ignore physics.
You've hit on the key innovation here. That's precisely the gap this system closes.
Things just floating in midair.
Right. So the next stage is geometric processing and something called voxelization. This is the part that acts like the physics police.
The physics police, I like that.
It imposes what you might call the grammar of building on the AI's imagination.
So this voxelization, is that kind of like turning a really smooth, complicated digital shape into something more like Lego blocks?
That is a perfect analogy, yes.
Yeah.
It simplifies the design into standard modular parts the robot can actually handle.
So structural cubes and flat panels?
For now, yeah. And they're connected by simple, reusable magnets. The system makes sure the whole design is actually buildable before the robotic arm even moves.
That's just, that's an incredible level of software orchestration. Marrying a digital design brain with a physical robot body.
It's a massive integration challenge.
Yeah. And, if you're listening and trying to connect these kinds of complex systems, whether it's for AI training, automation, or software integration, it helps to have specialized help.
This deep dive is brought to you by Embersilk. If you're trying to figure out where AI agents could make the most impact for your business, or you just need expert support with software development, check out embersilk.com for your AI needs. They can help turn those complex ideas into real action.
And building on that, the real intelligence comes from the vision language models.
Like Gemini 2.5 Pro.
Right. They provide what's called function and geometry-aware reasoning.
Yeah.
It's not just about what an object looks like, but what it's for.
So it understands that a chair needs panels on the seat for support.
Exactly. But a lamp would need panels on the shade. And human evaluators preferred the VLM's choices over 90% of the time, compared to just random or rule-based designs. That really democratizes the whole process, doesn't it?
Yeah.
You don't have to be a 3D modeling whiz anymore.
Not at all. And think about the sustainability angle.
Oh, of course. The components are modular.
You can just disassemble the shelf and tell the system to build you a stool with the same parts, practically zero material waste.
And you're still in charge of the process.
Absolutely. It's a human-in-the-loop approach. If you don't like the design, you just talk to it.
I want panels on the seat.
And it refines the design. You are co-creating with the AI, you always have the final say.
The pace here is just genuinely inspiring. And the researchers are already looking ahead, right, to scale this up.
Oh, yeah. They're planning to move beyond magnets to more robust connections. And this is the really exciting part, using small, distributed mobile robots.
So a whole swarm of little robots.
To build structures of almost any size, we are rapidly approaching a future where the physical world around us can be generated and reformed, well, just with our voice.
If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.